Hello and welcome to another episode of Ctrl Alt Defend. My name is Dirk Prinsloo, and in today's episode we're going to take a look at something that's been pestering the world of identity security. But before I do, maybe just some context, right? So many years ago we used passwords as a way of authenticating, which were great back then, I guess. But we well know today that those passwords are stupid. And the reason they're stupid is because people think or decide those passwords. Along came something that was going to fix that. Well, it still is fixing that. And that is called multi-factor authentication. Don't get me wrong, multi-factor authentication is still something that every organization needs. However, it is not foolproof. So what we're starting to see a trend nowadays is something called MFA Relay Attacks, right? Or sometimes it's also called adversary in the middle phishing attacks. And in today's episode, I'm going to take you through what it is and how the attacker gets this done, right? What kind of tools they use. So first of all, let me explain what it is. So first of all, the attacker sends a phishing email to the end user. I don't know, maybe something about a OneDrive document that they need to, review, or I don't know. But there's a link in the email. And what do users do? Of course, they click on the links. They are then presented with a login screen. But it's a fake login screen. But the users don't know that. Why would they know? How would they know? Right, so they are going to create or provide their username and password. And this is in fact functioning like a reverse proxy. The attacker is actually going to take that information and pass it on to Microsoft. That then in turn sends the authentication or that prompt to the end user device. And because they're expecting it, yes, you guessed it, they approve it. Of course they're going to approve it. The attacker then goes behind the scenes, and because of that approval, they take or steal the credentials, right? The username and the password, but very more importantly, they take the authenticator token, right? So they steal that, and then obviously they just go and use that against the correct or real login screen, as pretty much game over from there, right? They've stolen your stuff, they've gotten in. All right, so how does this all work? What does this from an attacker's perspective look like? Meet Evil Jinx. Now, Evil Jinx is probably just one of many tools out there that are used for this purpose. If you want to know more about Evil Jinx, I'll leave a description or a link in the description of the video, and you can go and check it out yourself. But let's take a quick look at a demonstration of how this actually works. All right, so first of all, to set the scene, you've got a conditional access policy that says require multi-factor authentication because we trust MFA, right? But let's take a look at how this actually gets done. All right, so first of all, the user clicks on the link, right? And they are taken to a login page that looks very much legit. But if you take a look at the URL, we know it isn't. But the user still continues to provide their credentials. The attacker's fake site functions, like I said, like a reverse proxy. So it just passes that on for the MFA prompt to actually get sent. And the user then obviously approve that. And what's happening in the back end is, the user is directed to some kind of login screen or some fake demo page here. It looks like an office page, but it isn't, right? It's fake. But let's take a look at what the attacker actually stolen, right? How does this actually look like? So here we can see that both the username and the password has been stolen, right? That is in clear text, right? We've got that. But right at the bottom is the important one, that in the blue text. That is the session token, right? That has been stolen by the actual attacker. So let's take a look at what that looks like after we've stolen that. So since a conditional access policy exists that requires MFA, the username and password is obviously not going to be enough, right? But the session key contains that information. And here we can see it's pretty much just a copy and paste exercise if you've got the right browser extension, right? Just paste it in. And basically the attacker now has access to an authenticated session to the real environment, right? We can see here is logged in already. But that's not all, right? Since it's authenticated, the attacker can pivot to other areas, such as, I don't know, Azure or Entra ID, and then start doing all kinds of weird things, right? So that's not great, right? But it's as easy as that. That is how easy it is. And then it gets really bad because if the attacker has now gone in with that authenticated token, the attacker can even visit My Security Info and register a FIDO2 security key as a login method, Now, obviously, since this counts as strong authentication method, the attacker does not need to know the password for the user going forwards. And even a password change is not going to change that. Something else that they would also probably try and do is, if the attacked user has the ability to join a device to enter ID, or even enroll a device into Intune, the attacker is just going to do that, right? And get a compliant device, enroll their own device, right? And it's compliant, and you'll be able to bypass all of those security implementation based on device compliance anyway. Right, there's another link. I think this is not new. I mean, Microsoft made this aware some time ago already. I'll leave a link to that in the description. But, you can kind of see that, it's pretty much game over from there. So what do we do about it, right? I guess the best thing that we can do is use strong authentication, right? So things like FIDO2 security keys or pass keys. And the reason for that is because the public-private key infrastructure is basically saved on your device. The attacker can try with that FIDO2 security key and try and register a key, but because we've already set up that strong authentication, the attacker is not going to be able to do that. So he's never going to get in, right? But there are other things we can do as well. The first thing is obviously require that device to be marked as compliant. Obviously, don't let your users just join any device to enter ID. That's the other thing I mentioned. But since those access controls rely on additional telemetry from Intune, or maybe a valid device certificate on the client device, this type of phishing attack is completely prevented. And there are more things that we can do. There's a range of things that we should be doing. Again, I'll leave a description to a link of a blog article in terms of on what I've based today's presentation and session. But go and have a look at the recommendations. There are a range of things that we have to do. And that's, I guess, all I wanted to show for today. Thank you very much for watching. As always, remember to subscribe to our YouTube channel. And yeah, guys, stay safe. Thanks for watching. Ciao, ciao. Bye-bye.